Hello everyone. So this small video is about me using Gemini for creating a prototype of a game that I was going to use for my research. Now I have been making games for a while and I know how everything is set up. So when I started to work with Raylib, I knew that I can easily make a game in it, but then I thought that I have been doing this thing for a very long time, and yes, I can make it. So, but at the same time, I should concentrate on the research aspect rather than the coding aspect of the game that I was going to make. So if Gemini creates a game for me, so I can always make it better. I don't need to do the groundwork for that. I can easily understand the code and then work on it. So I came across this Harper's blog, and here he says like what is his LLM code gen workflow at the moment. So if you read through this, so you understand like what kind of methodology he is using. I'm not following exactly what he is doing, but it's a really good read, and if I remember, I will put this link over there. Otherwise, you can read it over here if I forget, but I will make it a point to write that in the description. So how it starts is that you open Gemini and you give it a statement, and its statement goes like this. Over here. So you open Gemini and you write, ask me one question at a time so we can develop a thorough step-by-step spec for this idea. Each question should build on my previous answers, and our end goal is to have a detailed specification I can hand off to a developer. Let's do this iteratively and dig into every relevant detail. Remember, only one question at a time. And you then write, here's the idea. And my idea was I want to make a brick breaker game where a ball bounces on the paddle and breaks bricks using Raylib. The speed of the ball can be adjusted within the game for different levels of difficulty. The paddle needs to be controlled by moving mouse left and right. I am using a potentiometer to control the movement, so we'll map the mouse x-axis to the potentiometer values. So potentiometer is basically a device which manipulates the resistance of for the voltage. So normally when you are using a fan, like you have a ceiling fan, you want to turn it faster or slower, so that is where you're using the potentiometer. So I was working with Raspberry Pi Pico, and what I wanted to do was I wanted to move the paddle using the potentiometer rather than a mouse or a keyboard. So this is some research I'm doing, so that is what I wanted to do. But in order to make the potentiometer work, I needed a game, so I wanted to make a game. So this research specifically focuses on the hardware aspect, and I wanted to link that hardware to the software. I want the game to be engaging and with a lot of variety and hooks so that the user stays engaged. For some reason, this last part, it didn't really do a good job for that. So I had to come up with these things myself. But you can see like how Gemini goes about it. So then it starts with what are the dimensions, width and height you envision for the game window. I say that it's 1024 by 768. That should be a minimum and should support all types of screen resolution. So it stuck with this. It didn't cater for the other types of screen resolutions, which is fine. So then it's responded, okay, resolution of the game will be this, but then it said what percentage of the screen width do you want the paddle to occupy at the minimum resolution. So now what it is doing is saying that okay, there's a paddle at the bottom which you will be moving, so how big the paddle should be. So if I change the resolution, the size of the paddle will change, and accordingly the size of the ball will change and the size of the bricks will change. So all of that it will base on this resolution, and it will do all of that in code. So Gemini will produce code for that. So I said 10%, and then what is the range of the potentiometer? It's asking 0 to 255. I said 0 to 100 or 0 to 1. I'm not sure at this point. So what it did was, like I said, I'm not so sure, so it just pick 0 and 100, which is just fine, because even if it's 0 to 1, then I can always multiply that with 100 and we'll get the same value as this. So that's not an issue. And then based on that, it says should the full range of potentiometer correspond the full width of the screen or more. So now what it wants to do is it wants to map the 0 to 100 value to the full width of the screen. So which means like it's 1024 will be equal to 100 and 0 will be 0. So now that is what it is asking over here. So I said full width of the screen, and it gave this answer. So Let's consider vertical position of the pedal. How far from the bottom of the screen should the bottom edge of the pedal be positioned? So you can see. So I said 5%. So you can see, like, I say that, okay, if this is the complete screen, if the complete screen is 100%. So if you divide it into percentage, so you just take it 5% over here, so the pedal should move around at this area. So this is what it is doing. It's asking me one question at a time. I kept on going. So it's if you go through this, it keeps on asking me all these different questions, which will help it in creating the game. So for example, I said I need to have different colored bricks. So if the brick is light blue, it should break in 1 hit. If it's green, it should be in 2 hits. If it's yellow, break in 3 hits, and gray is indestructible. But then I correct it as I say that if a 3-hit brick gets hit, its color changes from red to yellow, and then yellow to green. So it was saying that it should be yellow, the red brick, but then I say that, okay, once it hits, so then it effectively becomes a 2-hit brick. So then the 2-hit brick should have the yellow color rather than the 3-hit brick. So that is what I'm saying. So it just made the corrections accordingly, and then it's kept on asking me more questions, like how the level progression should be. So it says that if the levels are 1 to 3, the 100% of the bricks will be one hit bricks. As we go to level 4 to 6, so 80% will be 1 hit, and then 20% will be 2-hit bricks. And then it laid out like how the levels should be designed. Then we are talking about bonus level over here. So we kept on doing this for all these questions. Remember, it was asking me one question at a time. So this seems like it's a lot of work, but it's not. It's actually, it just takes it doesn't take that much of a time. So at this point, for some reason, Gemini crashed, but the good thing was it saved the interaction over here. So I opened it up and I just said, okay, Gemini, just do this, and then it generated me the Python code, and it completely forgot what we were talking about. I wanted to C++ code, but or you can say C code, but it gave me the Python code. And then I said, look at the recent Brick Breaker game spec discussion we had. I want to continue that discussion. So then it looked at the discussion it had, and we started off from here, and it said that, okay, we have done this and this is what we should be doing. I said, no, that is enough, and now that we have wrapped up the brainstorming process, can you compile our findings into a comprehensive developer ready specification? So it created the complete specification over here. So with this specification, like if you have this specification, you can easily create the game I want to make. So it gave the function, non-function requirement, a technical design document, and everything. It gave me that, and then it asked me what should be art style. I said it should be retro, and finally I asked it to generate the code. So it gave me this code, and what you can do, like if you get this code, you can just copy the code. And I went to where the source is. So this is one of the source files. I come over here, I open it up in Visual Studio Code, and this is the old code. This is for another project. I'm not using this, so I just replaced that with the code that it gave me, and then I'll just save this, and then I'll go to File, Open Folder, and then I'll point it towards its Brick Breaker, select folder, and I should go to over here. And this is the main code file that we need to open, and we just write function F5. That should work. And I do something wrong. So we come to this, and it starts just now building it up. I think it will work. Oh yes, so it always so it says that the brick color light blue, it doesn't identify light blue. I think that is again, it's taking code from somewhere, and the light blue is not defined in Relib, so I just change it to blue, and I run this again, and Takes a while, but it should work. Normally it's faster than this, but since I'm recording at the same time, so I think that is why it's taking. So you can see that now the game has been created, so the game will work as we intended, and I haven't written a single line of code till now, so I just made one correction and the game will work as I wanted it to work. And yes, there are some issues, but these are very minor issues which happen with this game. But you can see that from here I can easily work with this game. It's made in Relib. It has a score and everything. It has the ball, the colors, and the bricks, and it's working as we intended it to work. And this is a good starting point for what can do something wrong. So we come to this and it starts just now building it up. I think it will work. Oh yes, so it always so it says that the brick color light blue, it doesn't identify light blue. I think that is again, it's taking code from somewhere, and the light blue is not defined in Relib, so I just change it to blue and I run this again, and normally it's faster than this, but since I'm recording at the same time, so I think that is why it's taking. So you can see that now the game has been created, so the game will work as we intended, and I haven't written a single line of code till now, so I just made one correction and the game will work as I wanted it to work. And yes, there are some issues, but these are very minor issues which happen with this game. But you can see that from here I can easily work with this game. It's made in Relib. It has a score and everything. It has the ball, the colors, and the bricks, and it's working as we intended it to work. And this is a good starting point for what kind of project I want to make. So this and then once I was done with this, I made some changes. Then what happened was I wanted to make more changes. So for example, we had decided from the beginning that it should start by 2x4 grid, so I can easily change to 2x16, or maybe let's make it 4x16. It will generate that, and I can change the size of the pedal. So it has given all the sizes the pedal width over here. So I just make it 0.2. It will be a slightly bigger pedal width. Yes. So it will be slightly bigger, and the ball radius is, I think the ball was a bit big, so I will make it 0.1. I make this changes, so you can see that I don't have to create all this code, and Relib did it for me. There was once one error which was easily fixed, and I started working with this, and then I can make changes to code to suit my needs. So let's run it again, and now we should have a slightly different game, but you can see that I can easily make those changes. And I understand like what is happening in this code. There's nothing that I don't know, but it just saves me a lot of time to come up with this code. I can easily ask Gemini to make any code for me. And now based on the changes, you can see that the pedal is bigger, there are more lines, and I can make changes to the code as well. So there are still some errors in it, and unless you know a bit of coding, so you will not be able to solve those errors. So it's I would recommend that once you are good at coding, so you can easily use Gemini to generate code for you, and this becomes a very fun experiment, and it also saves a lot of time. So yeah, this video was all about using LLMs to get the job done for you in faster time. So yes, I don't really want the students to use Gemini unless they know what they're doing. So once you know like how the code is written, and how the code is written, and if you can read a code written by other people, so you can see like this is some error in it. So I had fixed this error. So maybe I should show the game I turned it into. So let's open folder. work. Not here. Okay, it's let's go back. So it's breakout enhanced. So select folder, and so yeah. So let's run this. Again, I'm recording at the same time, so that's why it's taking this long to work. Normally it doesn't take this long. And I think you will be surprised at the game that was created in the end. Of course, I had to use Gemini. I also had to use the real documentation to get some things right, because Gemini is not always correct. So it thinks it's correct, but it's not. So now again, I'm recording at the same time, so that's why it's taking this long to work. Normally it doesn't take this long. And I think you will be surprised at the game that was created in the end. Of course, I had to use Gemini. I also had to use the real documentation to get some things right, because Gemini is not always correct. So it thinks it's correct, but it's not. So now you can see there's music, there's